Now we're carrying on this bonding worksheet. So we want to know sodium reacts with fluorine to give sodium fluoride. The reaction is very exothermic. What is meant by the term exothermic? Right. Exothermic is when a reaction gives out heat energy to its surroundings. This is probably the best definition. So it'd be good to learn that actually. Right, there's the electronic configuration of a sodium atom. Let's look at this quickly. You have one shell, two shells, three shells. That tells me straight away, yep. It's in period 3 in the periodic table. Remember, periods run across that way. And if you run downwards are called groups. And across rows, the columns are called groups and the rows are called periods. Periods tell you how many shells you have, how many electron shells. So because this has got 1, 2, 3, it's in period 3. Let us get rid of that. Right, another thing, because it's only got one electron on the outer shell, we know it's in group 1. Right. One more thing. It's always good to revise this. Put this into your head and then start tackling the exam papers. Right, let's do the electronic configuration. So on the first shell, I have 2 dot. On the next shell, shell number 2, I've got 8 electrons. Where are the 8 electrons? Look, 1, 2, 3, 4, 5, 6, 7, 8. So it's 2 dot 8 dot, and there's only one there, 1. So that's the electronic configuration for that. Right. Which of these diagrams shows the electronic configuration of a fluorine atom? Right, what we're gonna do is look up fluorine on the periodic table. Right, fluorine is here in group 7. No. Group 7. And it's got 9 electrons and 19 protons. Right, I'll tell you what, let's go copy this across. Right, let's try that again. 19 and 9 fluorine. So this here is called the, it's called the atomic number. It stands for the number of. It happens to be the same as the number is equal to the number of electrons. This is called the relative. Let's write it out for relative atomic mass. Relative atomic mass. RAM. It stands for the protons and neutrons. Remember, neutrons have no charge. Neutron equals no charge. Right, that's fine. That's all that done. So we're expecting 9 electrons, yeah. We're expecting, right, look, this one's wrong straight away. It's got 1, 2, 3, 4 on the first shell. This has got 1, 2, 3, 4 on the first shell. You're only allowed 2. So that's got 1, 2. That's got 1, 2. But we want 9 We want 9 electrons because we have 9 protons. So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9. So it's that one. This has got 10. So it's this one. Alright, let's keep going. Sodium ions and fluoride ions are formed when sodium reacts with fluorine. Sodium is a metal, fluorine is a non-metal. Metal plus a non-metal equals what sort of compound? There you go. Alright, this is a fluoride ion. It's gained this electron, so it's got an overall charge of minus. Right, sodium ion. Right, let's go look for sodium. So sodium is 23, 11. So it's got 11 protons. So it must have 11 electrons. So we're looking for the ion though. And we know sodium is in group 1, so it'll lose 1 electron to become a. So it would have had 11 electrons, it lost 1, so we're looking for 10 electrons. So look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. That's right, but this charge is wrong. We're looking for a 1 minus. I tend to put -1, but it's 1 minus. Right. This has got 2, 4, 6, 8, 9, 10. That's right, but it's got the wrong charge. That's a +1. That's a 1 plus, although you don't have to write the 1. So it's not that one, and it's not that one. That's got a +2. We only want a +1. Oh, silly person, I've done it again. Too busy concentrating on other things. We're expecting a. This is the one we want. Right, because that's given the wrong charge. Let's get rid of these. Let me go through that again. Probably just cause a load of fitting out and confusion. Right, okay, there. Right. So we've lost an electron, so we've got +1 charge. So we're expecting +1, and this is the one. Why is this not it? Because it's got +2. And why is this not it? Because it's -1. Right, okay, let's look at this. Right, whenever they talk about high melting points and boiling points, and they've also said that we know this is metal, non-metal, so it's ionic. Okay, so first of all, if it's a high melting point, you say sodium fluoride has a giant ionic structure, or you can use the word lattice. That is like a repeated pattern. Okay, and then and it has, how do we finish it off? Right, I'm writing on this just to show you that it's a different. So look, you need to learn that, and then it has strong electrostatic forces of what? Attraction between what? Between what though? That's the question. Between positive. You could put the name of the sodium, positive ions. You could put positive sodium ions and negative, and you could put fluoride ions, negative ions, right? And so what? Which require lots of thermal energy to break or overcome. That'll do it. There you go. Right, next one. Magnesium is an alloy of aluminium and magnesium. So have you noticed normally metals have layers, right? When you introduce different size atoms, just say for want of a better word, atoms, you disrupt the structure. So now if I apply a force that way and I apply a force, just say that way, because they're not even, it requires more force for these to slide over each other. That's what's going on. So what is an alloy? So you can just write it as it is, and learn it this way. It is a mixture of two or more elements, and then just finish it off by saying one of which is a metal. Just leave it like that. Right, it's a mixture. Oh yeah, okay, it's a mixture. I think that's enough for that. Right, okay, 3 marker. We want to find out why magnesium is harder than aluminium on its own. Right, so remember what we said, the regular structure in the layer of atoms that you have normally like this, that's disrupted. Now it looks like this. So it's not quite what it used to be. If you apply a force that way and a force that way, it's harder for these to slide over this big one and this big one to slide over that. So do you know when you're trying to slide them? Anyway, let's carry on. The regular structure of the atoms is broken, is disrupted. No, let's not use the word broken. I don't like the word broken. I think we should say distorted. Is distorted. Right. Why? Why is it distorted? Because I'm just splitting these up for you so then you can learn them in sort of sentences. Why? Because the magnesium atoms are different size, or in this case are larger than the aluminium, not aluminum as our American friends say, aluminium atoms. So what happens then is, this is what happens, I think. So it is more difficult to do what? Okay, 4, that was a quick recovery. VAR for difficult for the layers to slide over each other, There you go. Right. Look at the last one. Right, we've got now, this question is about metals, metal bonding. Which statement describes, okay, electrostatic forces of opposite, no, it's not that. Electrostatic forces between two nuclei, nope, that's covalent. That was ionic. Electrostatic force between positively charged particles and yeah. Between two atoms, no. Aluminium is malleable. Remember we said two words you need to learn? Malleable, you can flatten it into sheets. Ductile. Ductile. Ductile, that means you can draw it into wires. Right, and the answer is, why is that the case? Why can you do that? Is because the layers of ions can slide past each other when a force is applied past. That's the reason, but they're not asking that. It can easily be shaped so it's malleable. What are the two properties of aluminium make it suitable for saucepans? Right, it's good conductor of heat. And what else is there? Okay, it's got a higher or high melting point, so when you're cooking it won't sort of soften and start deforming. And what other things can we see? Okay, it's got low density, so it's not heavy when you lift it, especially the bigger pans and bigger pots. Right, it's not it's corrosion to it's resistant to corrosion, as in what rust on you? In what rust on you? In that sense, rust for want of a better word. So, for example, an iron one, if it's not stainless steel, it'll start rusting. Right, I think that was it, you know. Right, okay, that was a tough one, but it's done. Really useful. Go through it. Inshallah, you'll be all right.